This is 6.2, lesson B. I don't know why it says 2B, but this first one is very similar to 6.2a, the introduction, but you'll notice that the shaded region, there's two different regions you have to be concerned about. So this first one, so it's the region bounded by the two functions f of x and g of x. So you have this section down here, and then you have the section above. I'll shade a different color. I'll do it, not gold. I'll do green. And there's a difference between these two because you'll notice the one I'm shading right now, the gold function is on top and the black function's below. But if you look at the other function, the blue section, the black function's on top and the gold function's below. And so when we're finding those areas, we have to do it in two separate integrals. But the first thing you need to do is show or find where these graphs intersect. And you don't look at the graph and assume what they are unless they tell you those intersection points, and sometimes they do. But what I require you to do is you would have to tell me x equals x cubed, and now you'd get a point for that, knowing that you're trying to find where the two functions are equal to each other. Now let me label these graphs for you. This black graph would be g of x, and the gold graph would be f of x. Now to solve this, the mistake people make often is they'll divide both sides by x. You don't want to do that because you're assuming x is not 0, because you're not allowed to divide by 0. And so you're assuming 0 is not one of the roots, but it turns out to be, so that's bad. So we should subtract x from both sides. And now you factor, you take out the common factor of x, and you factor x squared minus 1 becomes x minus 1, x plus 1. You set that equal to 0, you get negative 1, 0, and 1. And so now we have found the three intersection points, negative 1, 0, and 1. So that's the first part. Now, how do you find the total area? We are going to find the area of the blue region first. So in the blue region, we're going to add up a bunch of rectangles. That's what the integral sign says. We're adding up. We're going to start at negative 1 and end at 0, because we found negative 1 and 0 were our first two intersection points. And then we need the height and the width of these rectangles. So I'm going to draw a representative rectangle. That's not a pretty one. So that's a general rectangle. Ooh, I don't like blue. Let's fill it with lime. Lime's good. So what's going to be the height of that? It's going to be the bigger y value minus the smaller y value. I'll call this h1. The bigger y value is the black graph, which is x cubed, and the smaller y value is the gold graph, which is x. So there is my height. And how wide is this? The width of that is a change in x. If you take that value and that value, the distance between it, you're subtracting the x's. So that's going to be a change in x. So I put a delta x. Excuse me. But in the integral, we're going to get x cubed minus x, and our width is dx. So that's going to be for the blue graph. So for the lime section, the green section, I'm going to add up all the rectangles, starting at 0, ending at 1. Why 0 to 1? We found 0 to 1 gives us the region of the green. Let me draw a representative rectangle, one of the many. And there we go. So what's the height of these rectangles? Let me thin this out. I'll call this h2. And again, it's the bigger y minus the smaller y. Bigger is higher, smaller is lower. So it's the gold minus the black, which would be, the gold function is y equals x, and the black is y equals x cubed. So it's x minus x cubed. And notice it's different here. They're flipped. And so you're going to get different answers on those regions, or different heights. So on the second integral, we're going to do x minus x cubed instead, dx, and add those up. Okay? So let's do this. The antiderivative is going to be x to the fourth over 4 and x squared over 2. And the antiderivative here is going to be x squared over 2 minus x to the fourth over 4. Let's plug in 0. When you plug in 0, you're going to get 0. Then you subtract and you plug in -1. So let's do that. So that's the first integral. The second integral, you're going to plug in 1 first. Whoopsies, 1 to the fourth. Then you can plug in 0, but if you see, it's clearly just going to be 0. Okay? Let's keep going. Don't forget there's a negative there. That's going to get you in trouble if you do. And we get that. 1/4 minus 1/2 is -1/4. And 1/2 minus 1/4 is positive 1/4. The two negatives make a plus. So you get 2/4 or 1/2. And that is the area of the regions. Now, one thing you could have done, you could have noticed this is symmetrical. The area here is equal to the area there. So you could have said, you know what, let's just find one area and double it. So you could have made that argument and done that. But that's how you find the area when there's multiple regions. You have to find the different heights. They're going to change from region to region. So be careful about that. Now here's another one. You can pause. This is going to be a calculator one. You can pause and try this on your own on the calculator, and then come back and see how I do it. Or you could just watch a little bit of the video to get a hint and pause. But try to practice this one. So the first thing you need to do is find these intersection points here. So how are you going to do that? I would expect you first to say sine x equals sine 2x. That will give you a point just for saying I need to find when these are equal to each other. So on your calculator, you're going to find those, and I'm going to show you a few things. I'm going to call this first one A, this B, and this C. And so while I'm here, I'm going to say at A equals, B equals, and C equals. You're finding the 3 points where they equal each other. And just to help my windows, you'll see it's from 0 to, I'll say 4. So maybe -1 to 4. And maybe -2 to 2. That's going to help me pick my window to get that part of the graph. But let's go ahead and practice on the graphing calculator. We're doing sines, so you have to make sure your calculator is in radian mode. So let's get this calculator back. All right, here we go. So hit mode, make sure, a few things here. Make sure that you are in radian mode here. If you're not, your answers are going to come out weird. So one function is going to be sine x. So do sine, your x is here, and parentheses, down arrow. Then I'm going to do sine 2x, and the parentheses. Remember in the window, I believe I said I'm going to go from negative. Remember, negative, not minus. If you do minus, it will be so confused and you'll be confused. I think we're going to 3 if I remember right. No, maybe it's farther. I think it's 4. Let me go to 4. And my y, I think I said negative 2 to 2 when I looked at that graph. And let's graph this. Okay. I think that's good, right? Yeah, that matches up. So that's A, that's B, that's C. Let's find the intersection. Second calc. Intersection's 5, so I hit 5 here. And I'm going to move this closer. Now it's asking, what's the first curve? Is it the blue one? Yes, enter. Is the second curve the red one here? Yes, enter. And guess. So guess, you need to do this so it knows if you want this intersection, that one, or that one. As long as you're anywhere close. What some people do, they'll put the blinky bob right near the intersection and say, okay, that's the answer, 0.0227. That is not correct. You have to enter your guess. I'm going to guess there. After I enter, it gives me the answer, and it's 0. So that one was easy, 0. So I'm just going to put a 0 here, and I'm done with that. Now for this next one, that was A, but 0 and A are so easy. I'm just going to put 0 instead of A. I need to find this intersection point, so second calc, intersect is 5. Is my first graph y1? Yes. Is my second graph y2? Yes. I'm going to guess that's 1 there. I'm going to guess it's about 1. There's the answer, 1.047. I'm going to store that in my calculator. So how do I do that? I go to my home screen and I say, hey, take the x and store it under B. So I'm going to put B. And so that 1.047197 number, I'm going to stick here. 1.0471976. And we have one more to find, which is C. So I'm going to go second calc, intersect. First graph is blue, y1, yes. Second graph is y2, yes. Guess. Looks like about 3. I'm going to hit 3, enter. And it's 3.1, that's pi. That's pi. So the answer is actually pi. You could put 3.1415927. That's fine. I'm going to store that. So I'm going to say, hey, take the x value you have there and store it as C. Oh, I'm not supposed to do that. I'm supposed to go home screen first. Okay, try it again. Take the x value that you found and store that as C. And now that's stored. So let me go back and say this is 3.1415957. And so first part is done. Now you have to find the area of the two regions. And let me label these graphs for you. The sine x has a period of 2 pi, so it's got to be the black one. The black one is your g of x. Oh, f of x, sorry. And then this has a period of pi, so that's going to be the gold one. This one's your g of x. So in this region, that first rectangle, I'm going to add up all the rectangles from A to B. A was 0 and B is B. I stored that. And the big Y is the gold, g of x, minus the small y, which is the black, f of x, dx. And then I need to add these rectangles. So those rectangles, I'm going to start at B and end at C. And I believe I stored that as C, if I remember right. And that's going to be f of x minus g of x. Now, since this is a calculator problem, I don't need to actually put the functions here, because by putting g of x, I've actually put that. And by putting f of x, I've actually put that. So you don't have to actually write the functions as long as they're predefined. Now, back in my equation, my y1 was sine of x. So for your own reference, you could put a y1 there and a y2 there to help you. Or in this case, this would be y2, y1, y1, y2, just to help you remember. So let's try this. So 0 to b, y2 minus y1. And this will all be done on your calculator. So we'll enter this in the calculator. So I have my functions there. So the first part, hopefully I have it written down right. It's going to be math 9 to get integral. Starting at 0, I'm ending at b. And was it y2 minus y1 or y1 minus y2? It's actually, it's y2 minus y1. So I'm going to do y2 minus y1. And then I want to add to that the second integral. So I need a math 9 again. And it's going to go from b to c, because I already saved those earlier. And this is going to be y1 minus y2. So y1 minus y2 with respect to x. And I get 2.5 for my answer. It's exact. So you just got to be careful. It's exactly 2.5. You can, if it's exact, just put 2.5. But I'm going to put the 0, 0, just be safe. You always need 3. But if you're not rounding off, technically you don't need those because it's exact. Okay? So that's how you would do the second example on a calculator. So as a reminder, make sure you show that you set them equal to each other. I'd probably give you a point for finding the intersection points. I'd probably give you a point for knowing which integrals to use and the integrands here, and 1 point for the answer. So it's a rough breakdown. I don't know exactly how it is break down the scoring here, but that's kind of how we would do that. All right, here's an interesting one. I'm going to ask you specifically to use horizontal rectangles. And why would you use horizontal rectangles? Sometimes you have to. In this case, you actually have an option. What you could see, if I did a rectangle here, and I did a rectangle here, you would notice those rectangles are different. The height is the black minus the blue. But here the height is the gold minus the blue. So you'd have to have two separate integrals. One from 0 to 4, and it'd be the black minus the blue. And then one from the gold minus the blue, from 4 to 6. Now, that's not bad in this case, but there are cases where you have to do a horizontal. It makes no sense to not do a horizontal. And because of that, you need to learn the horizontal. So I'm going to force you, in this case, to do a horizontal rectangle, which I'll draw right there. And this one, you just got to be careful, because this width is no longer a change in x or delta x. As you move up and down, what changes? The y value changes. So the distance from here to here is a change in y, not a change in x. So that's delta y. Let me label these graphs for you. This is f of x. The gold one is g of x. And the blue line at the bottom is h of x. So you have three functions, that function, and that function. Therefore, you have the blue shaded region. Okay? Now, we need to find intersection points. We'll do that. But let me just point out some things here. We'll call this the length of this. The length is going to be the distance from here to here. Okay, how do you find that? You'd have to take the x value here minus the x value here. It's the big X minus the small x. Now when we had vertical rectangles, it was the big Y minus the small y. Now that it's horizontal, you have to take the big X minus the small x. Very important to see that. And you shouldn't be memorizing it, it just should be obvious. So we're going to do big X minus small x, and we'll talk about that. So you guys might say, that's easy, I understand it. It's going to be the gold g of x minus the black f of x. That's going to be g of x minus f of x, which I know is going to be 6 minus x minus square root of x. And you might be excited, but that is wrong. And I'll explain to you why. So this function I can write like this, all of these. A function gets you y values. Here the y value is always 0. Yep, always 0. Here the y value is 6 minus x. So this is actually big Y. That's small y. Those are y values. They're not x's. Look, it's y equals. When you put 6 minus x, you're putting the y value there. And you don't want the y value because the y value here and the y value here are the same. They're both 1. 1 minus 1 is 0. That's very bad. You don't want to do that. So understand, if it's big X and small x, you need x equals, not these. These are wrong. Okay? So what do you have to do? You have to solve for x. So in this case, if I square both sides, I'm going to get x equals y squared. That's my x for f of x. This one, I want to solve for x. I'm going to subtract 6 from both sides, but I need to get rid of the negative sign, so I'm going to multiply both sides by -1, and I get that. Now I know the x value at those 2 points. Now big X, which is going to be the gold line, which is g of x, big X is going to be 6 minus y. And what's small x? Small x is the black line, square root, which is y squared. That is now the correct big X minus small x. You need to change them to x's. That's an x, by the way. So make sure, if you're looking for big X, find what x equals, not y equals. You don't want to know what y is, you want to know what x is. Okay? So now we found our length and width of our rectangles, and we might say, I am ready to do this. I'm going to add up all the rectangles, and I'm going to do 6 minus y squared. I just simplified this. Got rid of the parentheses. And that's the length. The width is delta y, which we write dy. But now here's the next problem. Where do I add these up? Where are my rectangles? So your first rectangle is down here. And you should see you're stacking up these rectangles all the way up. So your last rectangle is here. So you're going to go from 0 to, it looks like 2, but we have to make sure it's 2. How do we do that? We want to find the intersection just like we did before. So we need to take our original equation and find where these two equal each other. Radical x equals 6 minus x. You get a point for making that statement. Oh no. How am I going to find that? Well, I can square both sides. X equals. Now, this introduces some issues when you square both sides, because all of a sudden, x, which couldn't be negative, now can be negative. So it introduces things. You have to be careful. But we'll be okay because we can see on our graph what we're looking for. We square that, and we square that. We're going to get 36 minus 12x plus x squared. I'm going to subtract x from both sides. I'm going to get x squared minus 13x plus 36. Hopefully this factors nicely. It's going to be x minus 9, x minus 4, I believe. 9 times 4 is 36. Negative 9 and negative 4 is negative 13. How did I do that so fast? Because I suspected this was 4. And to have a nice root of 4, I need x minus 4. If I had a 4, I need a 9 to get 36. So these two intersect at 4 and 9. But obviously I don't worry about the 9 because it's off the screen. So it's 4. So I verified as 4. Now this is square root of 0, 0. So I know it's 0, 0 there. So I have to add up all the rectangles starting at 0 and ending at not 4. That is an x value. I need the y value. I need g of 4. G of 4 is 6 minus 4, which is 2. So I know it's going to be to 2. The coordinates here I just found are 4, 2. And again, the rectangles start here, here. I keep adding. Where's the last rectangle? At 2. You take the y value of that. Don't memorize that. It should make total logical sense. Now the last step, I'm finding the antiderivative, 6y, y squared over 2, y cubed over 3, 0 to 2. This is the area. So plug in 2. Then you plug in 0, but they're all 0, so that's easy. Then we're going to get 12 minus 2 minus 8 thirds. 10 minus 8 thirds is 3 goes into 8 twice. That's 6 and 2 thirds. If I subtract that, I should get 7 and 1/3 for my answer. Okay, so that's going to be how you do horizontal rectangles to find the area. All right. Now, you can try this one on your own. Use horizontal rectangles to find the area of the blue shaded region. Okay, you can go ahead and pause and try this on your own. This is a calculator question, by the way. Let's see how you do. All right, so welcome back. The first thing I want to find are these intersection points. And to help me out, I'm going to call this A comma B and this C comma D. I need the X and Y coordinates. I know need the Y coordinates because I'm going horizontal. So I need to know where I start and where I end, and that's the Y values there. So to get my first point, I'm going to say e to the x equals ln of x plus 4 at, and I know I have 2 points. I want AB and CD. And so I go to my calculator and let's plug those in. So let's do e to the x, clear that, e to the x, and we're going to do ln x plus 4. And what were our windows looking like? Looks like -1 to 2 and 0 to 5. -1 to 2 and 0 to 5. -1 to 2, 0 to 5. Now, if you don't know the windows, you have to just try something random. I like -10 to 10, and then work from there. But let's graph. There's the graph. So let's find our first intersection point. I'm going to do second calc. Ooh, I should use this. Second calc 5 for intersection. And is the first curve y1? Yes. Is the second curve y2? Yes. So I enter again. And then guess. You know what? Even if you don't get very close to that point, it's still going to work. But you have to hit the enter. Look, there are my points. I am going to save those. So I am going to go to my home screen and say, hey, whatever x was, I'm going to want to store that as a. Okay, now that's stored. And remember what y? Well, y is right here. It's the alpha function on 1. Alpha 1 is y. Hey, take what's in y and store that as b. Bam. So I have those stored. Now on these, I want to put those numbers in. So I had 0.5254696, and the y coordinate 1.05395. Yeah, it was something like that. Now let's find the other one. So we want to do second calc 5 for intersection. And yep, y1 is my first curve, so I hit enter. y2 is my second curve, so I hit enter. And I'm going to guess, that looks like about 1.5. 1.5 is my guess, and there it is. I'm going to store those, so I'm going to go to my home screen as C and D. Take what's in X, store it in C. Bam. Take what's in Y and store that is in D. Bam. Well, let me put that on my sheet here. So I get 1.479756 and the y coordinate was 4.3918778. All right, so I have found those 4 points. Now, I'm kind of almost done. What's my rectangle going to look like? It's going to look like that, but hopefully prettier. It's supposed to make it pretty for me. Yeah, like that. My width is easy. That's just going to be delta y. But my length here, that's going to be big X minus small x. But it's going to be the gold minus the black, but I need the x values. So these are the y values here. I want the x values, so I need to solve for x. Here, ln is the inverse, and so those cancel. X is ln y. I have found my big X. Now I need to find the big Y. Subtract 4 from both sides. How do you get rid of ln? The inverse function to that is e. So I e both sides so they cancel. And x equals e to the y minus 4. There is my small x. Okay. And so now let's find the area. I have to add up all the rectangles, starting at the lower value b, ending at the upper value d. So that's going to be from b to d, which I have stored in my calculator. And so the gold one is my big X. I never did that, did I? The gold one is my e to the x. So the gold one is going to be, that's the gold one. So that's the x version. That's going to be big X, ln y. My small x is this ln function, but once you convert that ln function, it becomes e to the y minus 4. So that's what I'm going to put in for my length. And my thickness is dy. Well, how do I put that in the calculator? Okay, in the calculator, it doesn't matter what this variable is. You can make it a q, a z, a w. It doesn't matter because the net area is going to be the same no matter what I call the variable. So when I put that in the calculator, I'm going to do it like such. So let's go to the calculator. Let's clear this home screen. I want to integrate to add up all the rectangles, math 9. I want to start at b, that's the lower y value, and I want to end at D, that's the upper y value. And I'm going to do ln y, but I don't have a y. I'm going to just do ln of x. End parenthesis, minus is e to the y minus 4. To get to the e, it's second ln. Instead of y minus 4, I just do x minus 4. Again, the variable doesn't matter. You're just finding a net area. And there's our answer. Wait, something doesn't look right. Let me double check. I had a different answer earlier, and I want to make sure I did this right. ln of x, e to the y minus 4. My b's and d's could be different. Let me double check my b and d. Let's do alpha b. Okay, that looks right. And let's check my d. That looks right. I'm not sure why this answer's coming out different, but I'm going to go with it. 1.678. 1.678. I'll double check that if it's not right. Oh well. So hopefully you guys got that. Well, hopefully I did it right, because I got two different answers when I did it two different ways, so, or two different times. But if it's different, I'll edit this out and redo it. All right, that's it. Bye-bye.